On 8.3 part 2. In this video I'm going to be working problems 11 and 12. I'm hoping that you've had the opportunity to either do this before watching the video, attempting 11 and 12, just to test your knowledge, or perhaps you could press pause right now and see if you could do these problems before I work through them. All right, so the focus of this video is really, again, to focus on those steps 2 and 3 and then making those summarizing decisions whether to accept or to reject the null hypothesis. So I've taken some steps here before the video to save a little bit of time. I've gone through problem 11 and I've written down the important information I'm going to need, such as the population mean. I've written down the number of people in the sample, the sample mean, and the sample standard deviation. I've also taken the step to write down the step 1, which I've clarified the null hypothesis is the population mean, which is the 3,252, and I'm asking, or my alternative hypothesis is that is there an increase, and that's where this greater than has happened here. I've also identified that in the problem my level of significance is 0.01, which will be important when I'm trying to find my critical value. All right, so let's get to it. So again, I've clarified in problem number 11 that my critical value will be, or my level of significance is 0.01. Because my sample is 20 people, my degrees of freedom is 19, and it is a one-tail. So I need to go to the t distribution here and look for 19 and a one-tail. I always make the mistake. Make sure you do this. One tail, 0.01 is right here, so that would leave me with 2.539 is my critical value. So critical value is 2.539. Okay, now I'm going to just draw a graphic here just to emphasize that. We know that we want it's greater than, so it's going to be a right-tailed. This is not drawn to scale. I'm just drawing it for just putting a representation of it. So obviously it'd probably be a little bit smaller, but again, I'm drawing it for the purpose of just visually. I'm saying 0.01. Okay, and my critical value where I'm making this assumption is 2.539. All right, so again, this is the critical area. This is the non-critical area that I have. So there's right in here, okay? So now I need to find the test value. I need to look at the data that I've collected. So I'm going to quickly do that. So we have the sample mean, which is 15,560, minus the population mean, which is 13,252, and then I'm going to divide by the standard deviation of the sample, which is 3,500, square root of the number of people in the study, which is 20. As you guys recognize, this is the exact same thing we just did in 7.2. So we're just finding that test value. And when you do this correctly on your calculator, type it in correctly, you would get a value of 2.949. 2.949. And what you'll recognize is that my test value falls actually in that critical area. Okay, so because it does that, I can say I'm going to reject the null hypothesis and say that there is enough evidence to support the claim that the mean cost has increased. So I'm going to reject HO and state, again, I'm not going to write this all out, that yes, there is enough evidence to support the claim that the mean cost has increased, okay, because it falls in that critical area when I took the test value. Okay, so again, let's clarify that 8.1 stuff just a little bit, in that because I'm in this critical area and that the level of significance is 0.01, I'm saying that I can reject the null hypothesis and accept the fact that there is a 1% chance that I could be having a type 1 error. Okay, and go back to 8.1 to look at that. But I think that idea helps you kind of realize what we're doing here, that I'm willing to accept a 1% chance that I have had a type 1 error, but again, that's pretty low, and so that allows me to reject the null hypothesis. All right, so let's try another one here, and let's look at this one. And I want to be clear here. If the standard deviation is 10,000, can the present conclude that there is a difference? there is a difference, whether positive or negative. So in this case, we're just saying the alternative hypothesis is that it does not equal 91,600, okay, which would emphasize the idea that we are dealing with a two-tailed situation, okay? So again, my level of, or my alpha is, let's see, 0.10, and my DF, degrees of freedom, is 27. And so this is going to be a two-tail. I just got to remind myself because when I look at the chart, I always make a silly mistake. All right, and let me show you this graphically here. So if we have, remember, if it's a two-tail, we split this on both sides. So we have a 0.05 here, the critical area on this side, and a 0.05 on this side. Okay, and this is a non-critical area in here. Critical area is on the side. All right, so my level of significance there, I need to go find my critical value. Where is this cutoff point where I'm going to make that judgment? All right, so I need to find 27, two-tailed 0.1. So two-tailed is 0.1 right here. I need to go all the way down to 27, right? 27. And so I should get two-tailed 1.703, okay? All right, so, and that is plus or minus 1.703 because you'll notice it's on both sides. So negative 1.703 and positive 1.703, okay? So in those areas, those created my critical values, non-critical, critical area, okay? So now I need to do my t-test. All right, so this is step number 3. Find that t-value. So t equals 88,500. Again, I'm using this formula right up here. 88,500 minus the population mean divided by the standard deviation, which is 10,000, divided by the square root of the number of people in the test. And we come out of the t-value of, on my work, I have negative 1.64. Okay, now you'll notice that negative 1.64 is right in this region right here, kind of roughly. I'll put it in green just so we can see it a little bit. So my test value falls in this region. Now you'll notice that it falls in the non-critical region. So that would mean step 4 says make a decision. Well, because it falls in the non-critical region, my test value, then do not reject the null hypothesis. Do not reject the null hypothesis. Or I accept the null hypothesis, okay? So in that answer, I would say there is insufficient evidence to conclude that the mean amount would be any different than the 91,600. Right? So hopefully this helps you out. Really quick, if I were to, let's say for example, I didn't do an example like this, but say it was the the alternative hypothesis was less than, then the number in our t-chart would be negative. Kind of what I did in the first video with C. So if you need to go back and look at that, just pay attention to that figure. Okay. Hopefully this video helped you out. Of course, office hours are always open, and have fun.